needed. If not, here we go. All right, so we're on 1A.5, and for 1A.5, we are covering, make sure we're sharing. We are covering 3 parts. Part 1 is exploring an exponential situation, and that is the part we're starting right now. So, exploring exponential situations. First, we're going to talk about what does it mean? What are the key features of an exponential function? Okay, so some of the key features of exponential functions are exponential functions grow or decay. Okay, they're going to grow or they're going to decay by equal factors over equal intervals. Remember, factors are something that we multiply by, right? Okay, terms are what we add, factors are what we multiply by. All right, next thing is our exponential functions have the form f of x equals a times b to the x. Okay, f of x equals a times b to the x. On your paper, I made a little typo. I think I accidentally wrote a C instead of a B on your paper. So where it says C for y'all, it should be a B. Do you guys see it? So it says where C, it should say where B. So change your C into a, so cross out the C and make it into a B. Got it? B is the base of our exponent. Do we see that? B is the base of our exponent, okay? If it bothers you, there's whiteout in your little bins if you really want to white it out and put a B, but either way, just correct it to make sure you've noted it. Okay, where B is the growth or decay factor and 0A is the y-intercept. So your A is your y-intercept. That's our initial value, our beginning, right? So we're going to write here, we're just adding the word initial. So when your A is your initial, your beginning. All right. Growth functions have common ratios. Okay. The common ratio means, remember, ratio is another word for fraction, right? I'm comparing 2 quantities. Okay. A common ratio greater than 1, whereas decay functions have a common ratio between 0 and 1. So growth factors, your common ratio, that means that your B value has to be greater than 1. Okay, for decay factors, that means your B value is greater than 0, but less than 1. Got it? Under A, it says initial. Oh. All right, so let's put some of this to use, okay? So if you open your little book, okay? At your table, I want the person wearing white shoes. Person wearing white shoes is going to read to the table, or the closest to white shoes, majority white shoes. You're going to read to the table about car depreciation. Whoa, wait, I lied. We got a video to watch. I tricked you. Joke. Not yet. Don't read to each other yet. Not yet. I just got really excited. My bad. And open. Okay, here we go. All right.
Let's say you want to buy this white Jeep Wrangler because, hey, it's summer and you're feeling frisky. Well, this model will run you nearly $50,000. But after you drive it off the lot, even just after 1 minute, it'll be worth $45,769. Now, why is that? The more you use a car, the less valuable it becomes. That's just simply depreciation. But that doesn't really answer why we lose 10% off the bat. Initially, when a car is listed at a retail price, there's actually a markup that's involved from the dealer to you. And this markup includes what the dealer is going to make. It also includes licensing fees and taxes that you're going to pay for the car. Once you drive it off the lot, though, the car becomes used, and the dealer's not going to want to buy it back from you at the retail price. They're just willing to pay the wholesale price because that's what they can get it for from the manufacturer. To get the best value on a car, always try to buy a used car after 3 or 4 years. That's when most of the depreciation has already occurred. Now, surprisingly, the Jeep Wrangler is one of the least depreciating cars, so that's good, but other cars aren't so fortunate. Let's say you want to buy this white Jeep Wrangler.
All right, how many of y'all knew that about cars? For the most part, yes. That as soon as you drive it off the lot, the car loses value. Like literally, it does. that you can return it, but when you return something, you usually aren't going to get the most money back for it. The reason why you're not getting the most money back for it is because it's lost its value. Okay, it lost its value. And so what you're going to do is now back to the person wearing the most white shoes at your table. You're going to read through this scenario here. And then at your table, you're going to devise a plan of how are you going to figure out the car's value over the next 10 years. Okay. Yes. Oh, how are you going to figure out the car's value over the next 10 years? So as the person reads, then you're going to take a moment and you're going to come up with a plan. Okay. After that plan, I'm going to, if your group is ready to share your plan with me, I'm going to come to your table and you're going to tell me what your plan is. Okay. I'm going to tell you if it's a good plan or a bad plan, and then you're going to go through with it. Okay. Your job of your table is to figure out what is the car's value after 10 years. That last column, we're going to do together. Does that make sense? Okay. You're doing the second column, the value after of the car after 10 years. The last column we're doing together as a class. Capiche? All right, get to reading. Go. All right, so guys, I heard a lot of good conversations going around and y'all are on the right track. Some of you did it, went a different route, but for the most part, you were getting there, right? So up first, it's at our zero. At zero, our car is worth 18,000. Agreed? Okay. After that, it says we lose how much every year? 20%. So we lose 20% of this 18,000 every single year. So first we have to figure out what is that 20%, right? So that 20% would be 18,000. And how do we turn a percent into a decimal? We are technically dividing by 100, but essentially you're just moving the decimal place 2 places to the left, correct? So that becomes 0.20. So after my first year, I lost $3,600 of value. Does that make sense? So year one, I'm just going to write this as a loss, but you don't have to write this. It's just so that I know that after year one, I lost 360, correct? Which means that at that end of that year, it was worth how much? Well, that would be 18,000 minus 3,600. So that's the value after year one. So after year one, it was 14,400. Agreed? Okay. I saw a lot of y'all had that part down. What I noticed is that instead of taking 20% of 14,400, you kept subtracting 3,600. And then what happened? You're like, oh, the car is worth nothing, right? At year five. Oh, no. No, it's 20% of its new value. So my new value now is 14,400. So I'm taking 20% of that. Does that make sense? So now on year two, I'm losing 2880, right? So now it's 14,400 minus 2880. And now my car is valued at 11,520. Yes? So now I'm going to lose how much of that car? So times 0.20. I'm going to lose 2,304. Your boxes are bigger than mine, so that's nice. And I don't want to keep typing things, so I'm just going to arrow up minus. That's the beauty of the calculator being updated, is that you can go grab what you need. And now I'm at 9,216. Now I'm going to lose some here, right? I'm going to hit enter. Times 0.2. And I lost 1,843 and 20 cents in value. Do we see that? To find out its new value, I'm going to grab, subtract, enter. And its new cost is, new value, I'm sorry, is 7,372 and 80 cents. Times by 0.20. And we get, I'm going to go grab because I don't want to type. If you like typing, go for it. But to me, this just seems a little faster to go grab. Hit enter. And I get 5,898.24. I don't know if you can grab on Desmos. I know you can copy and paste, but grabbing. And now I'm going to take 20% of that. So I'm going to lose on year 6. So now the new value is hit enter. And my new value is 4,000. Yes, ma'am. You found it. Yes. That's exactly what we were going to get to. Yes. Someone did it for me. You were the first person to start my third time teaching this lesson this year, and you're the first person to say it without me telling you. And why did you say that? Because you're losing 20%, but what are you retaining? You're retaining the 80%, right? So every year that you're losing 20%, you're actually keeping 80%. So instead of having to do this in 2 steps, you can do it in 1 step. And that 1 step is about what are you keeping? And I'm keeping how much? 80%. So notice here on this value, instead of me typing times 20 and minusing, I'm going to type times 0.80. And it's going to just tell me my new value. So my new value is 3,774 and 87 cents. And that's because I'm retaining 80%. I'm losing 20, which means I'm retaining 80. I'm going to do it again. Now, after this year, what is going to be my new value? It's going to be 3,019 and 90 cents. I'm retaining 80% the next year, which puts me at 2,415 and 92 cents. And again, I'm retaining 80% again, which puts me at 1,932.73. Nope, 74. Got it round correctly. Okay. So do you see how understanding how the percentage works actually ends up saving you time in calculations? That 0.80 is what's called our ratio of successive values. Okay. So what ends up happening here is if when you're finding your ratio of success, remember a ratio is just a fraction. So when we're looking for our ratio, that is your y2 divided by your y1. Okay. If I was to take the second y divided by the first y, let's see what happens. 1,440 divided by 18,000. What do I roughly get? 0.80, right? Y'all see that? I get roughly 0.80, which is my 80%. Okay. So that's the value that you end up getting every single time you're dividing. So your ratio of success is saying, what is the ratio between here and here? What is the ratio between here and here? What is the ratio between? And guess what? They're all going to be 0.80 because that's what you're retaining every single year. Every single year, you are retaining 0.80. 0.8, 0.8, 0.8. What that 0.8 represents is your B value. Does that make sense? That is your growth rate. Your constant, sorry, not your growth rate. That is, can I go back to our notes page really quick? That is our common ratio. Let me hide Sylvie. So our common ratio, which is our B value, our common ratio is between 0 and 1. So obviously this is a what? A decay. And that makes sense, right? Because what is my car values doing? Decaying. So we can write an equation that represents this every single time. So our equation would be y equals, and remember, A is your initial value. What was our A? 18,000. Okay. Your B is your growth, your ratio of success. What is our ratio of success? 0.80. And that would be our equation that models this growth, this decay. So if I was to type this into the calculator, I can then see how long my car's value would last without having to keep repeatedly doing this. So I can go to y equals, and I'm going to type in 18,000 times 0.8 to the x. And I'm going to go look at the table. So I'm going to hit second graph. And are these not the values we were coming up with? Yeah. And then I can keep looking. I'm like, okay, this car is going to last me for a while. It's going. It's good. How long does it take for my car to be worth nothing? Well, let me see. It's getting there. It's getting closer, 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 closer. It's going. Still there. We're in some change now. For the car to be worth absolutely nothing, it's going to take a really, really, really long time. Because technically, I guess you can sell for parts. So it's going to take me 68 years of owning this car in order for it to be worth absolutely nothing. Okay? Do we see how an exponential model works? Yes. So you go to, now we made our equation and we go to y equals and we're able to type our equation in, right? Once we type our equation in, we can press second graph and it's going to take us to our table. Okay. Notice that in reality, this will never actually equal 0. That's because exponential functions have what's called an asymptote. Do you all remember that from Algebra 1? Should have heard it in Algebra 1. It has an asymptote. Is that imaginary boundary line that says you're going to get as close as you can to 0, but is it actually going to touch it? No. Okay. It's like being in the friend zone. No matter what you do, you're just stuck there, bro. Okay. Just letting you know. If she puts you there, you're there. All right. Accept your fate. And don't keep hope alive. All right. Okay. How do we feel about creating a model? Pretty easy, pretty straightforward. Okay. So there's two things we need for an exponential model. We need to know what our A is, and we got to know what our B is. And to find our B, we divide our Y2 divided by our Y1. Make sense? Okay. All right. So let's go on to our practice problems. So our percent of change class practice problems. All right. How this is going to work is that we're going to collectively try to identify initial values, write equations, and then answer the questions from there. Okay. A lot of this depends on your participation and you following along. So up first is the teacher do, which is the one that I'm going to model for you. We have here, Sandy collected 10 pounds of apples at an apple orchard. She is determined to eat 20% of the apples remaining every day after the day she went to the orchard. Write an exponential function to model this scenario and use it to estimate how many pounds of apples she will have left after 1 week. Okay. So pretty straightforward problem here. Our homegirl Sandy really likes apples, which is cool for her, you know. So let's see what we can do. All right. So the first thing we have to do is establish what is our initial. Sorry. What's our, I want a highlighter. Highlight. There we go. Our initial amount is what? 10 pounds. So she has 10 pounds of apples, right? Okay. She is determined to eat 20% of the apples remaining every day. So she's eating 20%. All right. So let's go through the process of what we have to first. First, we're identifying our initial. So step 1 is what is your initial? And our initial is 10 pounds. Your initial is your A, correct? Step 2 is to find our growth rate, okay? Your growth rate equals 100% plus or minus your percent. So in this case, what is our growth rate? We have 100% and she's eating, so that's going to be minus 20%, right? So 100% minus 20% equals 80%. So therefore our B equals 0.8. And it's not a growth, it's a decay. Step 3 is to write our equation. Our equation is going to be y equals a times b to the x. Do I have everything I need to write our equation? We do. So our equation for this model would be y equals, what's our a? 10. What's our b? To the x. Do I have enough information now to answer the question? So the question says, after 1 week, how many apples pounds of apples would she have eaten? Well, 1 week equals how many days? 7. So we're looking for after 7 days. So we want to know when our x equals 7. Can I plug that into my calculator and find out that value? Yes. So let me go handy dandy calculadora. I'm going to reset Sylvie second because I don't feel like erasing. Plus 712. And I'm going to come over here to y equals, and you can use decimals if you want. It's just easier for me to use Sylvie so I don't have to toggle between the screens. Okay. So we had 10 times 0.8 to the x. Here we go. I'm going to go to my table. And what value am I looking for? 7. At 7, how many pounds of apples did she have left? We're going to say 2.1. Is that fair? All right. So after 7 days, she had 2.1 pounds of apples left. She is really eating those apples up. How we feel? Good? Okay. So we found our exponential model. And then we found the answer to their question. Those are your steps. So step 1, identify your initial. Step 2, identify your growth factor, your growth rate, whatever you want to call it. Step 3 is to create your exponential model. Step 4 is to answer the remaining of the question. No one's like, this is terrible. Yes, I'm winning today. All right, up next. So it says Jenny is running a simulation to track the spread of a common cold. Her simulation uses an exponential function to model the number of people with the common cold. The simulation uses the function P of t equals 3 times 1.25, where P of t is the number of people with the common cold and t is the number of days. What is the initial number of people with the common cold in Jenny's simulation? And what is the growth factor of the number of people with the common cold? And what is the percentage change in number of people with the common cold? So based on our example, our vocabulary, things we've done so far, you are now going to take apart the exponential model. Does that make sense? So your job at your group is to take apart the exponential model. So you're telling me what is my A, right? You're telling me what is my growth factor. And from that growth factor, what is my percent change? How much am I growing by? Okay. Can we do that? All right, I'm going to give you 2 minutes at your group to talk about it. Okay. And I will be around if you need me. Oh man, guys, I didn't realize it wasn't recording. So let me go back really quick so that if someone looks at the recording, they can see example number 3. Hey y'all, here's example number 3. Sorry, your teacher wasn't recording. Make sure you use the correct variables. All right, now we're on to example number 4. We'll be back. Resume. All right, so Peter's social media post receives 45 likes. Using a little bit of common sense, the goal of social media is that to grow or decay. Grow. So obviously in this problem, we should know that we're hopefully looking for a b value that is greater than 1, right? Because the goal is to grow. I don't think anyone on social media wants to lose likes, views, and follows, right? All right, so Pete, step 1 is to identify his A. What is his A? His A is 45. Step 2 is to identify his B. His B equals, in this case, 100% plus what? 15%. So therefore, if he's growing at 115%, his B value equals what? 1.15. Yes? All right. So now on step 3 is to write the equation. So his equation is y equals to the x. And there's a step 4 because it wants to know on the 25th day of the month what's happening, right? So the first day of the month, that's his day, that's his 0. So I just want to make a little point here is that for him, his 0 is first of the month. Does that make sense? His 1 would be the second of the month. That's because there's no 0 day in a month. Make sense? Okay. So keeping that in mind when you are figuring out what his value is, you have to do what? You have to subtract a day, right? So you're not actually finding the 25th, you're actually finding the what? The 24th. Does that make sense? Yeah. Did anyone catch that? No. Okay. That's because months do not have zero. There's no 0 day of the month. So when we're looking for the 25th day, that means that our x equals 24. Okay. Because we're looking for the 25th day. Our x is going to be 24. That's because our x's and our days are not the same. Okay. All right. So when I go to where my homegirl Sylvia at, I go over here. I'm going to put in my new equation. My new equation is 45, 1 and 15 to the x. I'm going to go, I either can go here. If I don't want to scroll all the way down, okay, I can go to the mode here after I've typed it in. Remember, you can press alpha trace and I can tell it what I want. I want the value at 24. Did I? Let me go look. I did put in 44. Thank you. So let's go back there again, and I'm going to go grab that again. And so after on day 25, on the 20th day, how many should I expect? Roughly 1,288 likes if it's only growing at 15% a day. Okay. So remember, there's more than one way of getting the value you want. Could you always just still go to the table and scroll down? Yes. Remember, you also can go to second window and tell the table to just go to 24. And then when you go to the table, it'll automatically be at 24. Okay. The other option is you can go to second window and you can go from independent to ask, which means that on my table, I can put in whatever values I want. So now I can put in 24. I can put in on day 100, but on day 101, how many will I have? Okay. So there's more than one way of figuring it out. Okay. Especially using technology. Desmos, you have your f of x feature, right? As long as you write it as a function, you can write f of x, you can pull up your table, and all the above. All right. Let's do one more. So in your group, you have Dante's problem. All right, so I'm going to bring y'all in a little quicker so that I'll have time to go over your assignment with you, okay? All right, so on here, Dante, our homeboy, he's like, ooh, I'm just going to wait it out. I'm going to wait 4 weeks. And after 4 weeks, all of it's going to be free, right? That's his thought process. So every week it says that until it's sold, everything is sold, the store owner is going to reduce the price of the remaining by 25%. So the first thing you have to do is establish what is your A, which is your initial. So before anything goes on sale on week 0, everything is 100%, right? So that has to be your A, but without writing the percent. Okay. So then on week next is establishing what is your B. So your B is I'm losing, I'm reducing, right? So I'm reducing, which means that it's going to be 100% minus 75%, not 75, 25. I just wrote the answer already. Again, you see nothing. Which is going to equal, so my B equals 0.75, right? So then my model is Y equals what? 100 to the X. Okay. So our homeboy here, Dante, said that at week 4, everything should be free, right? So when we are doing part 4, on part 4, we are testing Dante's guesstimation. So on 4, we want to know what is X at week 4. Does that make sense? And then we can determine was he right or wrong, correct? So when we go to our calculator, we pull up Sylvie. Okay, remember I'm just going to reset because it just makes my heart feel better. I don't feel like typing anything in. Second plus 712. And we're going to y equals. And I'm going to put in 100 times 0.75 to the x. So let's go look at Dante. So on week 4, is it 100% off? No. How much is he saving on? How much is everything now? It's 31% off. So Dante is incorrect. So on week 4, it's 31.6% off. Not correct, Dante. Okay. So instead, he is saving. So this is how much it's off, how much they're left. Yes. So the first, before the man started to sell, everything is 100%, right? At week 1, everything is now what? And then at week 2, it keeps going and going and going, right? So then how much is it left from the, well, not off, that's how much they pay. Sorry. Sell price. There we go. So that would be his sell price. Not quite at 100. So how many weeks would you have to wait in order for it to be free? Quite a while. You'd be waiting for it to be completely free. Dante would have wasted half a year, over half a year, if his theory is it to be free. Yeah, 35 weeks. By then, you should just bought it, bro. But all right. So how you feel? Not terrible. I'll take that. I will take not terrible. All right. So let's look over your assignment that goes along with this. For your assignment, you're going to be doing it on your own piece of paper. It's under your modules page. So under your modules page, I will update your table, your main page for the end of the day. But if you go down to your modules page, you should see 1A.5 exponential models. Do you see here? After, remember we did last week around the room function notations? And then we did here. Yes, on modules, we all see here. And it's going to load. It says on your own notebook paper, write your name, date, period, and title. You're going to number and complete the following problems. So on here, you have these problems to complete. By this time is said and done, you're going to live, breathe, and know exponential functions like the back of your hand. Okay? All right, on the last page, it looks like a lot, but all you're doing is telling me whether it's a growth or decay. Okay? So at the beginning, you're setting it up and answering the questions, right? 1 through 8, just like we did. On 9 through 16, no, I'm sorry, 9 through 12, you're telling me if it's a growth or decay. And then 13 through 16, you're telling me what was the rate. Okay? So what percent was I losing or gaining by? Got it? All right, does that sound doable? Does it sound fair? Does it match what we learned? Yes. Questions, comments, concerns about today or what is expected for you to do on your assignment? Okay, so I'm expecting on Wednesday that everyone is dropping this in the turn-in box. Yes? All right, remember, we're doing it on our own piece of paper. If you want to print it at home, you can. Otherwise, just take notebook paper, write your name, period, date, and title it, and just write number and solve. Okay? All right, thank you for a great Monday.